Hello students, good morning. So today we will continue with the revision session on database management systems and also data warehousing for DS students. As we know, the syllabus is divided into three parts called database design, implementation, maintenance. In database design, we have ER models, relational models, then schema refinement. We call functional dependency and normalization. And in the implementation, we have seen relational algebra and calculus and structured query language, SQL. And in a database maintenance, we have seen transaction management and concurrency control and recovery management and file organization and indexing. And for DA people, we have a data warehouse. Fine. So, we are going to discuss, we are going to review all the topics, and my discussion is according to the concepts through questions. Okay. When you see the weightage analysis of the subject, and these are the weightages of individual chapters from 2024 to 2017, you can look at most of the times we got 1 mark questions in ER and relational models, and most of the times it is a theory questions like in past this one, and before 2017 you got 2 marks questions also, and FD and normalization questions, and RE and RC, relational algebra and calculus, SQL, transactions and concurrency. And in recovery, there is only one question in 2021 when you see the past 7 to 8 years of papers. And indexing, you have a good number of questions. And look at the number of questions asked in databases are something around 5 to 6 questions are asking. And when you see the average marks will be 8 marks. On average, you are going to get 8 marks from the subject. So, 8 marks is not less, it is a good weightage. Okay. So, when it comes to the DA people, and that weightage goes to around 10 to 12. Now, 10 to 12 marks for DA students, and for CS students, I can say an average 8 marks, 8 to 10 marks from DBMS. And moreover, when it comes to the topics, the syllabus is common for data science and artificial intelligence and computer science people, and the topics of transactions and recovery is not there for DA people, it is only for CS people, that you know, and data warehouse is only for DA people. I am going to revise all the concepts in briefly, and we will go ahead with questions. So, through questions I am going to revise the topics. Okay, this is about weightage analysis. Then when comes to the first topic, entity relationship data model. First we will go ahead with the entity relationship data model. When you see ER models, what kind of questions were asked? In ER models, they have asked on ER notations. The questions on ER notations. This is the first thing. Questions on ER notations. What is entity, relationship, attributes, that notations of that attributes, like a multi-valued attributes is to be represented with a double ellipse, and ER notations. Last GATE exam, I think in 2021, they have asked how do you represent the weak relationship. The weak relationship is to be represented with double diamond. So, the ER notations is important. Just when it comes to the ER notations, like what is expected is called composite attributes, like how composite attribute is to be represented, attribute with attributes. This is a composite attribute. When it comes to the multi-valued attributes, we call double ellipse. And when it comes to the derived attribute, it is called dotted ellipse. The special notations I am showing you. And we have a partial key. Partial key is attribute with dotted underline, and a weak relationship is double diamond. Weak entity set is double rectangle. Weak entity set is double rectangle. And any special notations, hierarchical relationship, it is to be shown with is a, right. These are the some of the special notations, and generally instead of going with regular notations like entity relationship and all. So you may expect this kind of notations. What is the symbol? Which symbol will be used to this one? It could be 1 mark question. This is ER notations. And then you may be asked to give some scenario, second thing type of question. What you can expect is, you will be given a scenario. Scenario means some case study is given, and based on that case study, you have to draw ER model. This is expected type. I am telling you, this is expected type. And these kind of expected questions, I have included some of them in your test series. And draw ER notations, draw the ER model. And on ER model, you will be asked some questions like there is a partial participation, total participation, key constraints, cardinality ratios, and on conversion of that ER model, like how many tables are possible. These kind of questions are expected to be asked, and that kind of expected questions I have given included in your test series. Fine, this is expected. And third thing, you can expect questions on cardinality ratios. It is cardinality ratios. And parallelly, you may expect questions on conversion of ER models to relational models, and ask you to find minimum number of tables. And ask you to find minimum number of tables. And minimum number of tables is the old type of questions, but questions may be in a different way, like minimum table, maximum tables, like if this table combined with that table, what is going to be primary key, foreign key, that kind of way of asking questions may be different. Okay. So we will discuss, I am going to revise the ER models topic with respect to some questions. Now, look at this question, how the question was asked, and I am going to revise the topic through questions. Just have a look. Yeah, here, what is the question? The question is, suppose is part of, is a relationship type with two participating entity types, district and state. Okay. So, is part of is a relationship, is part of is a relationship between the two entity types we call district and state. District and state. Okay. Now, question is, what is a cardinality? What is the appropriate cardinality ratio for district and state? Now, what is appropriate cardinality ratio between the district and state? Like each state, like simple, each state can have how many districts? Each state will have many districts. So, many you write to the district side. And each district belongs to how many states? 1 state. So, what is the cardinality? Many to 1. So, what is the majority people have selected? Option C, perfect. Okay. Now, this is about cardinality. We have 4 types of cardinality: 1 to 1, 1 to many to 1, many to many. How you have to write the cardinality for a particular scenario? Simple. Say here, what is the possibility? Each district belongs to 1 state. So, you write 1 at the state side. Each state belongs to, each state can have many districts. So, district side you write many. So, it is called many to 1. So accordingly, you have to write the cardinality, means an entity of a site associating with how many entities of other site, maximum possibilities. That maximum number you write in the other site. Like each state, this entity, it is associating with how many entities of other side, you write in this side, so that you can define the cardinality for that scenario. This is about cardinality ratios. I'll give you one more question. This is slightly different. Just read the question and try to understand it. So sorry, yeah, voice was muted, mic was muted. So what is given? Assigned is a relationship. It is mentioned, it is many to one, with two participating entity types, employee and department. Employee in the one side, department in the other side. Between the employee and department, it is mentioned cardinality is many to one. Okay. Do you remember, if it is many to one, we have a key constraint. Now, key constraint is from which side? Which side? In many side. As I have discussed, if it is one to one cardinality, we have a both side arrow, correct? Do remember? And if it is one to many and many to one, we have a arrow from many side arrow. And if it is many to many, any key constraint possible? No key constraint possible. And these are the points we have discussed. Okay. So now if it is many to many means we have an arrow from employee to assigned. And what is the meaning of arrow? I am revising every point. What is the meaning of arrow? The meaning of arrow is called at most one. And what is the meaning of double line and arrow? Tell me, what is the meaning of double line and arrow? You can answer through chat. I will check. Okay, what is the meaning of double line and arrow? It is called exactly one. What is the meaning of single line? It is called 0 or many. Right? What is the meaning of double line? At least one. Fine. These are the notations that we have discussed. Fine. Now, what is mentioned up to this question? The cardinality is many to one. So that employee side arrow is possible. Fine. Look at a maximum of 7 employees are assigned to a department. Maximum of 7 employees are assigned to department. Means to one department, how many employees are assigned? Maximum of 7. Okay. Maximum of 7. To one department, how many employees are assigned? Maximum of 7. That is mentioned. Okay. And both are participating totally in the relationship. So we call total participation. So total participation is represented with double line. Here also double line. And here you observe that many value is 7. Means each department, in the previous question I also have explained, each department assigned how many employees? 7 employees. And anyhow it is mentioned many to one cardinality, means each employee assigned to how many departments? One department. That is the meaning of it. Okay. If in the ER diagram, the line that connects employee to the relationship, okay, this line, employee to the relationship, type assigned is to be labeled with x comma y using min-max notation. Choose the correct option. What does it mean? Employee is connected with minimum how many assigned relationships and maximum how many relationships. This one you can answer it simply. From employee to assigned, what notation is there? Double line and arrow. Double line, arrow. What is a double and arrow? Is called exactly one. Exactly one means minimum how many? 1. Maximum how many? 1. Correct? Minimum 1, maximum 1. It means one employee can participate with minimum 1 relationship and maximum 1 relationship, because double line and arrow is saying that it is exactly 1. So it is 1 to 1. Now minimum is 1, maximum is 1. That is an option B. Okay, now I will ask you, just you can answer in the Q&A. Now what is the minimum and maximum from department to assigned? Just take a minute of time and try to answer it. Here, each department, because it is a total participation says what? At least 1. That double line says at least 1. So, minimum 1, maximum already mentioned 7, finish. This is 1, 7, perfect. So, I hope you understood now how to answer this kind of questions, because majority of the students are posing the same questions. That option B is right. Okay. Chalo. What is the correct notation for the above ER diagram? This could be a multiple selection question. Go ahead. So, just 1 minute for the question. What is the correct notation for the above ER diagram? Just now I have told you what is the meaning of notations. This is called single line and arrow. Single line and arrow is called at most 1, and double line is called at least 1, right? And single line is called partial participation, double line is called total participation. Okay, question is about participations. Partial participation of E2 in R, but E2 we have total participation, and single line is called partial participation. So, partial participation of E2 is wrong, total participation of E2 is right, and total participation of E1 is wrong, and key constraint from E1 to R is correct, because it is an arrow, arrow is called key constraint. So, there is both B and D. Okay, perfect. This is a simple matching kind of questions. Consider the following sets and match the following set C with set D and answer it. This is because, as I told you, the questions are possible on notations. Na? So, which one will be the notations for which concept in ER model? That kind of question I have included by giving a match the following. Okay, go ahead with this question. Fine, nice. Here it is for match the following weak entity set. How weak entity is to be represented? Double rectangle box, right? Multi-valued attribute, double ellipse. Derived attribute, dotted ellipse, right? Derived attribute is dotted ellipse, and relationship is diamond box. These notations you need to know. And weak entity set is to be represented with double line rectangle, P matching with Y. So, P matching with Y, it means that A and D are wrong, and multi-valued attribute, it is to be represented with double line ellipse. So, Q matching with Z. So, in both of that, Q is matching with Z, and derived attribute is to be represented with the dotted or dashed line ellipse, that R is matching with W. So, that B is wrong and C is correct. Perfect. Majority students have selected, but again I am seeing few mistakes from students. Please don't do that. Here I am sharing the results also. If you want, you can check it, how many of you answered correctly, right? And these are the kind of questions possible exclusively from the ER models, right? What kind of notations, and mostly on cardinalities, you can expect a questions purely on ER models. When it comes to the combinations of ER and relational models, you can expect questions on conversion on ER models to relational models. Conversion type of questions are possible. And next we will see with relational models. In relational model, we have discussed a data in the database is going to be represented in the form of a table. Each table is called a relation. Each table is called a relation. We have discussed some of the basic terminologies, because on terminology also in the previous gate questions were asked. Like I have discussed in the during the live sessions and physical classes that one theory questions. What is RET says? Like, which of the following correctly describes RET? Right? What is RET? RET are also called cardinality of a relation, which is going to be represents the number of degree or RET. Degree specifies the number of attributes in a relation. There are certain options are given. So, means terminology is also important, because even 1 mark also very crucial for your admission into your IITs. Okay, what are the basic terminologies we have discussed. We have discussed about the basic terminology called relation, attributes, the basic terminology, and schema. What is a schema? Schema means structure. Instance, instance means tuples present in a relation, and we have discussed degree. Question were asked on degree. What is the degree? Specifies the number of attributes of a relation schema. On the schema, how many attributes are there? Called degree. And we have discussed about cardinality. Because degree it is asked already, you may expect question on cardinality. What is a cardinality? Specifies the number of tuples in a relation instance. Means at that particular moment of time, how many tuples are there is called cardinality. Degree, cardinality. Then we have discussed about integrity constraints. So you may expect a questions on integrity constraints, and because questions were already asked also, but still there is a scope of asking questions on integrity constraints. What are the integrity constraints? We have discussed primary key. As you know, primary key will not allow duplicates, will not allow null values. Unique. What is unique? No duplicates, but nulls are allowed. Not null, duplicates are allowed, but null is not allowed, and combination of unique and not null is called primary key. And we have a check constraint for defining your own conditions. And next we have a foreign key constraints. We have foreign key constraint. What for foreign key? To show relationship between the two tables. To show relationship between the two tables, we use a foreign key constraint. Okay. So, primary key, unique, not null, check, and foreign key constraints. And the questions were asked on foreign key constraints. And next we have discussed about the key constraints. I am going to revise the concepts through questions, like as I have done for the previous questions. In the key constraints, this is important. We have discussed about candidate key. And moreover, if any specific thing is, do you have any doubt, you ask me to explain it in brief, I will explain you, do not worry. Candidate key, because some of the students I have observed, even now, some of the students are confusing with candidate key. And what is a candidate key? It is a set of attributes which uniquely identifies a tuple, and that set of attributes which uniquely identifies a tuple is called super key. And that super key, if it is minimal super key, then it is called candidate key, right? So, when I can call it is a super key, assuming when it is called, it is a minimal super key, assuming if A and B attributes together is a super key. When we can call that super key is minimal super key, so that it is going to become a candidate key. So, I can say AB is a minimal super key if A alone is not super key, A is not super key and B is not super key. If A is not super key and B is not super key, then AB is called minimal super key. That minimal super key is called candidate key. And it is important, more number of times questions were asked on that minimal super key, candidate key and all. So, first thing, it should be a super key. Second thing, the subset should not be a super key. If the subset is not super key, we can call it as a minimal super key, and minimal super key is called candidate key. And one of the candidate key should become a primary key, right? One of the candidate key should become a primary key. And we know the relationship. Every relation should have one primary key. That one we have to select from the candidate keys. And every candidate key is a subset of super keys. Every candidate key is a subset of super key. Fine. This is the relationship between the key constraints. And questions were asked like which of the following is a candidate key, not a candidate key, which of the following is super key but not candidate key, like that. Combinations of questions are asked and possible to be asked. And more importantly, the questions were asked on foreign key constraints. Even still, there is a lot of scope is there for asking questions on foreign key. And what are the points that we have discussed on foreign key. Foreign key can allow duplicates and null values. What foreign key shows a relation between the two tables, and foreign key can refer to itself, means a same table can be act as a parent as well as a child. And we have discussed whatever the values present in foreign key in the child table, and definitely every value must be present in the parent table, but every value present in the parent table need not present in the child table. Means values present in foreign key definitely should be there in the primary key, but values present in primary key need not be present in foreign key, right? And violations, if you delete from the child table, means you delete anything from the foreign key, it does not causes any violation of foreign key constraint. But if you delete anything from the parent table, means in the primary key, and if you have a related tuples in the foreign key, then it causes a violation. It means inserting into the parent will not cause any violation, but inserting into the child will cause a violation. Means inserting into foreign key column may causes a violation. Deleting from the foreign key column will never cause a violation, but deleting from the parent table, means primary key column, will have a violations, right? And suppose if a tuple is to be deleted from the parent, the corresponding tuple is to be deleted in the child, then we use a condition on foreign key called on delete cascade. Along with cascade, we have set null, and also we have a set default cases. What will happen, it will allow deletion from the parent, and if deletion happened on the parent, what action to be taken on the child? Cascade. Cascade means same action on the parent as well as child, or set null or set default. Okay, these are the possibilities on the foreign key, right? These are the possibilities on foreign key: on delete cascade, on delete set null, on delete set default. So questions were asked on these points. Questions were asked on these points, and still scope is there for asking questions on foreign key constraints. So when it comes to purely relational models, the scope of asking questions on terminology, and there is a scope of asking questions on foreign key constraint, and there is a scope of asking questions on key constraints, more specifically candidate key and super key. Now we'll see some of the questions so that you can review we will review the concept, and also you can parallel, you can check your knowledge. Okay, fine. Suppose A1, A5 is the key. Combination of A1, A5 is said key, and generally key means it is called candidate key. Wherever they said just key, and keys means candidate key. For the relation R1 of A1 to A5, consider the statements given below. A5 may be a key. A5 is going to be a key? No, because a part of key never be a key, means part of candidate key never uniquely identifies. This is a false statement. And A1, A4, A5 is a super key. If it is to be a super key, what is required? It requires to have a candidate key, or we can call a super key is a superset of candidate key. Like A1, A5 already there, so its superset is always called super key. It is a true statement. A1, A4, A5 may be a key, but key in the sense candidate key. But if it is a candidate key, its subset should not be a key again. But A1, A5 already a key, it is called superset, but not because it is a superset. In that superset, its subset A1, A5 already is a key. So that it is a false statement, right? So what is the answer for this question? False, true, false. That is option D. Okay, A, B, C, D. Fine. That is an option D. Perfect. And look at another question on foreign key. There is a question on foreign key. Consider the following relation R of x, y, z with x as the primary key and z as the foreign key, referencing x with on delete cascade. Suppose x2, y2, x1 if deleted, as a result, what will be the number of tuples in R after deletion? Okay, try. So what was the question? Consider the following relation, right? R of x, y, z with x as the primary key. Okay. x is primary key and z as the foreign key, z is foreign key referencing x with on delete cascade. This is a foreign key referring x with on delete cascade. Suppose tuple x2, y2, x1 if deleted, x2, y2, x1, x2, y2, x1, this tuple if delete. Suppose x2, y2, x1 if deleted, as a result, what will be the number of tuples in R after deletion? Okay, the question is what will be the number of tuples in R after deletion? Means after deletion, how many tuples are there in the R, right? Look at, if this is deleted, what happens? Deleting from the foreign key will not cause any problem. Deleting from the primary key will cause a problem. Because on delete cascade means whenever you delete from the parent, means with respect to x I can call it as a parent, with respect to z I can call it as a child. Whenever a tuple is deleted from the parent, the corresponding tuple in the child also be deleted. It means x2 is in which tuples? In the z column. x2 is here, x2 is here also. In these two places x2 is there. So that this tuple is to be deleted, this tuple is also be deleted. And look at the deletion of the tuple, deletion of this tuple causing deletion of x3 here. Now we have to see any related tuples for this x3. That related tuple you have to check in the z column. In the z column, this is there. So it is also be deleted. Right? And here also look at, this is also there, this is also to be deleted, right? Fine. Now when it comes to this tuple, here x4 is deleted. So whenever a tuple is deleted from the parent, related tuples from the child also be deleted, but x4 is not in the z column. So nothing, on deletion of x4, y2, x2, nothing is going to be deleted. And so what are the other tuples deleted? Now this is deleted. Now deletion causes x5 deleted, but x5 is not in the child. And deletion of this tuple causes x9 is deleted. But do you have x9? We don't have x9 in the column. So what are the tuples that are left after the deletion? After the deletion, which tuples are left? This is a one tuple, and this four already deleted. This is another tuple. So means how many tuples are left after the deletion? 2 tuples. So answer for the question is 2. Is it okay? Look at. So where was a mistake you people have done? Now x2, okay, x2, y2, x1 deleted. Okay. Now I can call this is a parent tuple. For this parent tuple, what are the child tuples? Look, for this parent tuples, like x2 is deleted from the parent, x2 is a parent, and the related tuples that you have to look in the z column. Why? Because with respect to x I can call parent, with respect to z I can call child. Whenever a tuple is deleted from the parent, you have to look the related tuples in the child. What are the child tuples? x3, y1, x2, x3, y1, x2, and one more is x4, y2, x2, x4, y4, x2. Now, because you are deleting this x2, y2, x1, because on delete cascade option is there, it is to delete these 2 tuples also. This is and these 2 tuples also. Now, when you delete these tuples, it is causing x3 deleted. It means again it is treated as a parent. Now, if it is deleted as a parent, now it is to be deleted its child. So, means this x3 is in how many tuples? In the z column. That x3 is in the z column in which tuples x5, y4, x3. Just I am writing x5, y4, x3 and x9, y5, x3. x9, y5, x3. So because x3 is there in the child, whenever you delete from the parent, it is going to be child. Now it means it is a parent. For this, these are the childs. When these are deleted, now for this, these are the parents for these two children. That is also to be deleted. When x4 is deleted, we have to look x4 in the child. Now it is treated as a parent, its child. Like my father, for my father, I am a son. Okay. To me, my son is a like it is a hierarchy, right? So to my son, it is a grandfather and father and my son, right now. So hierarchy is to be maintained. Sarvesh. And for x4, we don't have x4 in the z column, means no child for this. And whenever you delete this x5, again you have to look its child. x5 is not in the z column and x9 is not in the z column, means these three do not have any children. For this, these two are children. For this, these two are children, and this does not have any children. That does not have any children. Okay. Next, the questions are on translations. So on relational models, purely you can see questions on purely on relational models. You can see questions on terminology, candidate key, super keys, and foreign key constraints. And when it comes to the translation of ER model to relational models, what questions you can see? In translation of ER models to relational models, we know that every entity set is represented as one table. And entity set is to be represented as two tables. Tell me if there is a multi-valued attributes. These things we have discussed. And every relationship set, it is to be represented as one table, right? It is to be merged with entity set when we have to merge if there is a key constraint. Do remember these points. There is a key constraint. And we have discussed about cardinalities in many to many 3 tables, in many to 1, 1 to many, and 1 to 1. In all the 3 cases, there are 2 tables. And what is a one table case? The one table case is 1 to 1 with total participation. I am just have insisted many of the students to write short notes, but some of the students, most of the students are not taking care about it. But I hope you understand the importance of short notes. These points are all I have told you in the class. 1 to 1 with total participation. 1 to 1 with total participation will give you total participation from both sides. Will give you one table, right? And these are the important points. On this, questions were asked. I have discussed every point. And again, I am repeating, short notes is important. If you keep on repeat these things, you never forget it. Okay. Any special cases that we have discussed, hierarchical relationship, aggregation, on that no questions were asked, but scope is there for asking questions. Okay. Right. I hope you recollected these points, correct? Now look at this question, consider the below ER diagram and find the minimum number of tables required. Just go ahead with this question and try to answer in the Q&A. How do you do this? One point I have explained during the live session also, E1 relation with E2. Say what we have discussed, if E1 is a key to E2, we have placed arrow here. So means one way of showing this notation is E1 to R, another notation is E1 to E2, both are same. Means it means E1 is participating with E2 through R with at most one relationship. So, when it in the case of at most one relationship, we can show E1 to R or E1 to E2, means either this arrow we put it or we put this arrow. But generally textbooks follows this arrow, but in one of the previous gate question, the arrow is given at this side, but both the meanings are same, means E1 to E2 means without this arrow, here only we can have, or else we can have only here, but we know this notation, we are following this notation because we are following the standard textbook notations. So, according to these notations, look at team to faculty, here arrow is there, according to our notation I can put here, but generally we put entity to relationship. Faculty to team is an arrow, so faculty to HOD we put an arrow, and faculty to belongs to is an arrow, so that we put here. Just I am converting into the notation that we have discussed, so that there will be no confusion. And rating to faculty is an arrow, so arrow you can put rating to lock. After that, once you place the arrows, you can go for mergings. And whenever there is a key constraint, means arrow is there to the relationship to be merged with entity set. So, okay, this is one merge, right, that is one. And here faculty with HOD and belongs to both are the arrows, so that we can merge faculty HOD belongs to, and here it is a unary relationship. It is a unary relationship, and team will have one table. And what about this relationship? This relationship cannot be merged with anyone else. So that how many tables it can have? It can have 4 tables. The number of tables are 4. Simple, keep an arrows and keep the arrows and count it. Keep the arrows and count it. Okay. So anyhow, because arrow is there, log is to be merged with rating. And faculty to HOD arrow, faculty to belongs to arrow, these two you can merge with faculty. And even we do have team to HOD, so team and HOD you can merge it, and faculty and belongs to you can merge it, but that not gives any difference. And but ACE preparation league does not have any arrows with a team, so that ACE preparation league will not be combined with team, it should have a separate table. So, how many tables are possible? 4 tables are possible. How did arrow came from team to HOD? Actually, because we have a arrow from team to faculty, right? So that we can call, actually we are following this notation, entity to relationship, but what is given means, as I just want to say, right? Okay. So, E1 arrow R with E2, this also can be represented as E1 R arrow is to E2, means you can keep arrow to E1 to E2 or E1 to R, both are same. So, I have converted into comfortable way, because we have followed this one. Is it okay? Consider the following relation and find the minimum number of tables in the relational modulus. How many tables in the relational model? Look at here, many means no arrows, one many means arrow is from many side. Do remember, today also we have revised this point. And because we have a 3 relationships, it is many, it is many, it is one many, and we know that many does not have any arrows. One many has an arrow from many side, okay, because it is an arrow from many side. Now, what we have to do? You merge this R2. You merge this R2 with E3. Merge R2 with E3. There is only one possibility. Any other mergings are possible? No. Okay, here maybe display issue, but you can observe it is a double ellipse. Double ellipse means multi-valued attributes. If you didn't observe because of display issue, no problem, but it is a E is double ellipse, E with has a double ellipse is for multi-valued attributes. If it is a multi-valued attributes, it is to be represented with two tables. This is 1 and this is 2 comma 3, like two tables. And there are no mergings of relationships. So, relationships should be separately, and this is a fourth table and this is a fifth table and this is a sixth table. Suppose you haven't observed this multi-valued attributes, because I can say that that is a display issue. So, if you don't take this as a multi-valued attributes, it cannot be represented as two tables, then your answer should be 5 tables. But if anybody observed this as a multi-valued attributes, then your answer should be 6 tables. Okay. Functional dependencies and normalization. Okay. In functional dependencies and normalization, what kind of questions you can expect? The type of questions are verifying, verifying FDs, functional dependency verification. Okay, verify the given functional dependency, means you will be given a table of data and asked to know which functional dependency is satisfied or not satisfied, and that kind of question. And second is about trivial FDs and non-trivial FDs. What is a trivial FD? When RHS is subset or equals to LHS of a dependency, then we can call it as a trivial FDs, and trivial FDs are always satisfied, right? Verifying FD, trivial FDs. And third type of questions. What you can expect? Verifying FDs and trivial FDs and additional FDs, means if you are given some dependencies and asked to find which of the following FD is satisfying on the relation. Suppose some dependency x to y, if it is to be verified, we can say x to y is possible if the closure of x contains y. That is a third type of questions, because on this type of concept questions were asked. And the fourth type, equivalences, equivalence of FDs. But equivalence of FDs so far not given, and I can say this is expected topic. And what kind of questions are possible to be asked, I have discussed during the live sessions and during the physical classes also. And fifth is on minimal set. And on minimal set of functional dependencies in 2017, only question asked, but after that and before that no question asked, but still scope is there for minimal set. Instead of asking in a regular way, maybe you may expect in a different way, minimal set of FDs. And sixth one, and finding the keys. And it is important, and different varieties of questions also we have discussed, and means regular type of questions were asked, but varieties of questions possible to be asked, finding the keys. That varieties also we have discussed. And next, properties of decomposition properties. It is also important, I can say, because questions were asked. Properties of decomposition. I am going to revise all these concepts with reference to questions. And we have two properties of decomposition, lossless join and dependency preservation, and how to verify lossless and dependency preservation properties, that we will discuss. Properties of decomposition, right? Consider the following relation: vehicles vehicle service, vehicle color, capacity, wheels, owner. With the following functional dependence sets, S1 we have 2 dependencies, S2 we have 2 dependencies. Which of the following statement is true? Neither S1 covers S2 nor S2 covers S1. Like, what is the meaning of S1 covers S2, S1 covers S2? It is meaning that dependencies of S2 you can get using S1. Dependencies of S2 are vehicle to color capacity. If you have to check this, we have to take the closure of vehicle in the S1, means checking S2 with respect to S1. In the S2, we have vehicle to color capacity. Now, is vehicle to color capacity is there in S1? How do you do this? By taking the closure of vehicle. When you take the closure of vehicle in S1, vehicle closure is vehicle only. You don't have that dependency. It means vehicle to color capacity is not determined by S1. Means this first FD1 not determined by S1. FD1 of S2 not determined by S1. So means S1 is covering S2? No, this is incorrect. So S2 covers S1. How do you say? What is the meaning? Dependence of S1 can be determined by using S2. Now FD1 you look at. What is the FD1 of S1? Vehicle color is determining capacity. So what you have to do? Vehicle color closure you have to find in S2, because S1 dependency is verified in S2. What is a vehicle color closure? Vehicle color, with vehicle we have a color and capacity, and that's it, right? But what is to be verified? Vehicle color to capacity. Yes, it is getting. So this is possible. FD2 of S1. S1 we have to check with S2. What is FD2 of S1? Wheel closure. What is wheel closure in S2? Wheel closure is wheel, vehicle, owner, because vehicle is there, color and capacity is there. What is FD2 says? Wheels determines capacity and owner. Capacity and owner, both. Sorry, wheels will have vehicle, capacity and owner, all three. Means this is also possible. Means S2 is covering S1, but S1 is not covering S2. So it is given option A, neither S1 covers S2 nor S2 covers S1. This is wrong. S2 covers S1, correct. S2 is covering S1, correct. But S1 does not cover S2 is correct. S1 covers S2, wrong. Both are wrong. So correct answer is option B. Now, how to find the keys? As we know it, if we have to find a key, the closure of that key should contain all the attributes. Suppose assuming some attributes, like some attributes that I am calling X, if X is going to be a key, the closure of X should contains all attributes. If the closure of X contains all attributes, then we say X is super key. If X is minimal super key, then X is candidate key and one of the candidate key will be used as a primary key. That we know it. And again, I want to repeat it. What is the minimal super key? Assuming the A, B attributes together, we call it as a super key. If A alone is not super key and B alone is not super key, then AB is called minimal super key and a minimal super key is called candidate key, right? A relation R has two candidate keys with 1 and 2 attributes. With 1 and 2 attributes. Now tell me, can you expect any common attributes? If it is a common attribute, if one candidate key is one attribute, another candidate key is two attributes. Suppose that one attribute of a candidate key is common with two attribute candidate key. If it is common, then it is not a candidate key, right? That point you should focus on it. This is a key with one attribute, this is a key with two attributes. If the same attribute is common, then two attributes is not considered as a candidate key, that is a super key only. So means these two are definitely different. Okay. So assuming this is A, this is BC. There are 40 super keys, totally 40 super keys of R. What is the total number of attributes in R? Now assuming total attributes are n. So we have to find n value. Because two candidate keys, one candidate key with one attribute, another candidate key with two attributes, then how do you find the super keys? To the power of number of non-prime attributes. So one attribute is candidate key, remaining attributes, with remaining attributes it will form a super keys. So how many super keys possible with one attribute candidate key, 2 power remaining attributes. So what are the remaining attributes? N minus 1 plus with two attributes candidate key, how many possibilities? 2 power n minus 2 possibilities minus anything common here? No common. If it is no common, 2 to the power of n minus of one candidate key plus one candidate key with one attribute, another candidate key with two attributes. So means n minus key attributes. Key attributes are going to be common in both of them. Okay, this is equals to how much? 40. Now you can go with a trial and error method, simple. If n is 5, suppose for n equal to 5, just randomly I am checking because 40 na, n equal to 5, 2 to the power of 5 minus 1, 4, 16 plus 2 to the power of 5 minus 2 means 2 to the power of 3, 8 minus 2 to the power of 5 minus 3, 5 minus 3, 2 means 4 equal to 40, true or false? 16 plus 8, 24, sorry, it is 2 to the power of 2, 2 to the power of 2, 2 to the power of 2 is 4, right? This is 4. It means equal to 40, wrong. So for n equal to 6, you can try. 2 to the power of 6 minus 1. 2 to the power of 6 minus 1 means 5. 2 to the power of 5 is 32 plus 2 to the power of 6 minus 2 means 2 to the power of 4, that is 16. 32 plus 16, 48 minus 2 to the power of 6 minus 3 means 2 to the power of 3, 8. 32 plus 16, 48 minus 8, 40. This is correct. So the number of attributes are 6. Normal forms. Next, we'll go ahead with the normal forms. We started with unnormalized relation. When I can call a relation is unnormalized, we can say a relation is unnormalized. It is not a normalized relation. If it has multi-valued or composite attributes. If we remove multi-valued attributes and composite attributes, we can say the relation is we can say relation is normalized and we can call 1NF. What 1NF allows? Only atomic values. Only atomic values are there in 1NF. And if you remove the problem of partial dependencies, partial functional dependencies. And do remember what is the format of partial functional dependency? Left hand side should have part of key, right hand side should have non-key, then it is called partial dependencies. If you remove the problem of partial dependencies, we can say relation is in 2NF. And what 2NF allows? Only full functional dependency, means no partial dependencies, full dependencies are allowed. But 2NF suffers with the problem of transitive dependencies. It requires to remove the problem of transitive dependency. Recollect what is the format of transitive dependency? Left hand side non-key, right hand side non-key. It is called transitive dependency. If left non-key, right non-key, it is called transitive dependency. If transitive dependency is there, we have to remove to make the relation into 3NF, 3NF had a rule that if x2 y is a dependency, if x2 y is a dependency, x is going to become super key or y should become prime attribute. As you know, what is the meaning of prime attribute? Prime attribute is attribute of a candidate key, right? Either or condition. But 3NF suffers with a problem of prime transitivity. So, if we remove the problem of prime transitivity. Now, what is the meaning of prime transitivity? Left hand side prime attribute, right hand side prime attribute, we call prime transitivity. Then we can say relation is in BCNF. Now, when I can say BCNF, if a dependency x2y is there, x should definitely be super key, nothing else. Then we can call relation is in BCNF. So, what is the format of PFD? Part of key to non-key. What is the format of TD? Non-key to non-key. What is the format of prime transitivity? Prime attribute to prime attribute. And here for you I will write partial dependencies had a point part of key to non-key. Transitive dependencies means a non-key is determining non-key, and a prime transitivity means prime attribute determining prime attributes. And these cases we have to look. And what normal form says? The highest normal form condition. The highest normal form condition we can say BCNF, if not then we have to say 3NF, if not we have to say 2NF, if not we have to say 1NF, if not we can say unnormalized relation. And as I told you, this slide in the live classes and the physical class also I told you, this summary and this slide is helpful to get 2 marks easily in your exam. Consider relation schema. It is given class ID I, class link L, subject S, mentor M, duration D. And we have okay, options are given, the dependencies. The question is which of the following set of functional dependencies should be chosen such that online class be in 2NF but not in 3NF. When I can say a relation is in 2NF, no partial dependencies. When it is not in 3NF but transitive dependencies. So, means no partial dependencies but transitive dependencies. No partial dependencies means no part of key to non-key, but transitive dependency expecting means non-key to non-key should be there. Okay, right. In the case of first one, what is a key? It seems class ID is a key, okay, because when I take the closure of ID closure, I closure will take I, L, S, with L we have a D, I, L, S, D. I, L, S, D, M is not covered, M is not covered, L, S, D, L, S, D is there, I is not a key. So, M is, what is M? M is independent attribute. When you take the closure of M, M closure is M, S, not getting all attributes. So, to M if I add I am going to get all the attributes. I M closure is I M with I, L, S, D is there already. So, what is the key for the first question? The key for the first question is I and M. If I and M is a key, M is part of key, S is non-key. So, part of key to non-key. Majority people have selected option A. Anything wrong? Anything wrong from my side? Because when majority is selecting option A, I am just thinking about it. Now, what is the key here? I and M only, na? Means class ID and mentor together is a key. When class ID and mentor together is a key, mentor is part of key, subject is non-key. It is called partial functional dependency. If it is partial dependency, it is 1NF. but not in 2NF. But question is, it requires to be in 2NF. Option A is wrong. So majority is going wrong. Almost 46% of the students selected option A. Please check where you have done a mistake. And please try not to do the same mistake. Next, when you look for the option B, what is a key? ID, okay, I'll write with some different color. Is it visible, blue color? Or else I'll go with some different color. So option A is wrong. Look for option B, class ID comma link. When I take the closure IL SMD, all I am getting. So IL is a key. When I am taking MS closure, I am going to get MS class link duration class ID. I am getting all. Means for both of them, left hand side is super key. So therefore the relation is in BCNF, right? But it said clearly should not be in 3NF. If it is BCNF, it is also in 3NF. So that option B is incorrect, because it is BCNF means it is also 3NF. And 13% of the students also selected option B. So B is also wrong. And look for option C. 33% of the students selected option C. Okay, check option C is correct or not. I'll write with some dark color. And here class ID and mentor. Class ID and mentor. If I take a closure, so that is going to be a key. Class ID comma mentor closure. That is ID, mentor, link, subject. With link we have duration. So I can call I and M is together is a key. So class ID and mentor together is a key. Remaining all are non-key attributes. It means class link is a non-key attribute. Duration is a non-key attribute. Non-key is called transitive dependence. If a transitive dependency is there, relation is in 2NF but not in 3NF. It is in 2NF because no partial dependencies, but not in 3NF. Okay, 2NF but not in 3NF. So answer is option C. C is the correct answer. Okay, check for last option D also, just for the reference. Last option D, class ID to class link. So by looking we can understand ID comma link is a key. If ID comma link is a key and here mentor to class link is there. So link can be replaced with mentor. So IM is also key. Here we have a two keys. When we have a two keys, we don't have part of key to non-key, but instead we have a prime attribute to prime attribute is there. We call it as a prime transitivity. Because prime transitivity is there, it is in 3NF. If it is in 3NF, it is also in 2NF. But it says in 2NF but not in 3NF. But it is already in 3NF. So that option D is also wrong. Okay. So instead of simply giving dependencies and to find what is a normal form, you may expect a question like this. That's what I am telling you. This time questions are not regular types. Questions will be slightly different. Relational algebra. What you can expect in relational algebra? Undoubtedly it is very important, because so far from this chapter majority of the questions were asked. So maximum number of questions asked is this chapter. No much concepts, but the way they have asked more number of questions on algebra. And calculus is less number, like on fingers we can count it, but algebra is very, very important. In relational algebra, you have a basic selection operator for selecting the rows. For selecting the columns, we have a pi, we call projection operator for selecting columns. And we have a set manipulation operators, union, intersection, difference are called set manipulation operators. And we had a manipulation, and it is an assumption that no duplicates, that is important. no duplicates in the output of relational algebra, no duplicates in the output of relational algebra. Then we have discussed about a cross product to compare the data between the two tables. We use a cross product, or we call Cartesian product. And also we have a joins, it is a join operator, and more questions asked on joins, and a join operator to combine the two tables. And next division operator, this is also important, and these are the topics. But on basics only, multiple questions are combined. Like if I want to say a question on foreign key, that I can frame with algebra. So that a foreign key constraint with algebra question combined to get a beautiful questions. Like this, there are multiple questions asked on algebra. So more scope is there for getting more questions on algebra. So this time I will expect minimum 2 questions from algebra, at least one 1 mark and one 2 mark questions. 2 questions from algebra I am expecting. This is my sense says. Okay. P cross R, first table and last table, Cartesian product. What tuples to be selected? QD greater than 1. Okay. PQ, right? Sorry, P and Q. Fine. 1 minute. The P and Q, P cross Q, first table and second table. QD greater than 1. QD greater than 1 means the last tuple you ignore it. Remaining all are QD greater than 1. Okay. And one more condition is QB equal to PB. QB equal to PB. So B and B should match us. Right. 3 equal to 3, correct match. And 3 equal to 3, this is also correct match. And this 3 equal to 3, this 3 equal to 3. And this 4 had a match with this, and 5 does not have a match. These 3 are the matches. For these 3, we have to get A. What is the A? 1 and 2. What is the A? 1 and 2 is the output of this first query. When you look for the output of second query, look at the output of second query. Second query is P cross R. It means first and last. RE equal to 12. RE equal to 12 for these two tuples. And what is another condition? PB equal to RB. PB equal to RB. Now what is this B9? Had any match? No match. And here 4 had any match? Yes. This 4 had a match with this. That is a match. Only one match is there. What it is selecting? Pi A. What is the A for this? 2. So means here the second query is giving answer 2. First query is giving answer 1, 2. Second query is giving 2. And between them we have a minus. Because between them we have a minus, 1, 2 minus 2 will give you 1. That's it. So what is given? What is the number of tuples in the result of the relational algebra expression? How many tuples are returned? Only one tuple is returned. C greater than 5. Now just I am looking for the Q. What is Q? BD. C greater than 5, C greater than 5, this one. BD is 5, 2. And C greater than 5, that's it, only one, na? 3, 2, 1, 1, 3. So C greater than 5, only one. Now what is P division Q? P is ABCD, division with BD will give you AC, which AC is matching with only 5, 2, because only one is there. Here 5, 2 in BD. Here 5, 2 in BD. So AC 1, 3 is matching. And 5, 2 in BD. AC 2, 6 also matching. And 5, 2 here, 5, 2 and AC 1 1 is also matching. It is 2 5, but 5 2 is expecting, it is 2 5 not matches. So means what is the output? 1 3 2 6 1 1. 1 3 2 6 1 1, that is there with option D. So D is the correct answer for the question. Right, when it comes to the SQL, undoubtedly SQL is very important. But only the thing I can say about SQL is practice, practice, practice. The more you practice, the better confidence you will get it. On SQL, when I have to talk about SQL, from SQL on basic questions and basic SQL queries, very rarely questions are asked, like maybe 1 mark questions. Like basics means like what are the types of operators we have. Like we have in, and, are, not, between and, like, on this kind of operators, some basic questions. Very rarely asked, but it is not that completely it is not at all asked. So, some basic questions were asked. When you look for 2023 gate question on SQL, on a basic query is only SQL question asked, but that too 2 marks question asked. But that is funny on 2023 gate exam. But look at, you can expect questions on basic operators and like basic operators, set manipulation operators. What are set manipulation operators? Union, intersection and set difference. Set manipulation operators. And we know that set manipulation operators eliminate the duplicates, okay. And we have a questions on group by and having. Something 2 to 3 questions were asked on group by and having class. This is a bit interesting, sorry, bit more important. And then we have a questions on joins. Questions on joins. You will be given a tables of data and a join query is given and asked to find the output of the query. Joins. And more importantly, in this join, we have a outer join. More questions are asked on outer join and some questions are on self join. But self join not asked in the previous gate, it is expected. It is expected topic and outer join is important. And then after the outer join, the more important is subqueries. More questions asked on subqueries. And the subqueries we have nested queries. So means 90% of the chances are there to get a questions on subqueries. Nested queries, correlated subqueries, and set comparison operators like any and all. Queries on any and all. Set comparison operators. These are the questions on subqueries. Nested, correlated, set comparison operators. Any, all. Fine. Consider 2 instances of the relation R1 and R2 with number of rows 10 and 8 respectively. The question is the minimum, not about maximum. The question is about minimum number of tuples in the result of the following query is. What is the query? Select star from R1 natural full outer join. Okay. When it comes to the maximum, if assuming R1 and R2 does not have any attributes in common, it performs a cross product. So 10 into 8, 80 combinations are possible. If there is no common attributes, the 80 will be the maximum. But question is about minimum. So minimum means there will be a match. If there is a match, then will be a minimum possible, right? And because it is a natural join, so what is the possibility of matchings? The number of matchings, minimum matchings. For every row of R2, we have 1 row in R1. Because when I'm finding every row of R2, 1 matching row in R1, so there are 8 maps. 8 matchings are possible. If 8 matchings are there, it means in R1 we have 2 more tuples that does not have any matches, 2 non-matchings. That's it now. Because it is a full outer join, will give you both matching and non-matching rows. So totally how many is possible? 10 is possible. That is option C. In the subqueries, definitely I can say it is very important. We have a nested queries, correlated queries, and set manipulation operators. In the nested query, first inner query is going to be evaluated, and the result of inner query should be given to outer query, right? So means inner query is independently executed and the result is given to outer query. Based on the result of inner query, outer query will find the final output. So evaluation is inner to outer or bottom to top. When it comes to the correlated subquery, this process is important to understand. According to the process, you evaluate the query, you will get the accurate answers. Query execution will start from outer, and for the row of outer, it is going to execute the inner query, but final output will be the tuple that is there in the outer query. It means the result of inner query will be given back to the outer query. Based on the result of inner query, outer query will be decided whether that outer query tuple to be considered for the final output or not. This is correlated query. In the correlated query, one of the important class is called exists class. What for exists? It means it requires to check whether result is there in the inner query or not. If you have a result, in the inner query, it returns true. Exists class, if no results, means empty set. It is going to return false. It means result not exist. So questions were asked on exists, correlated query, nested queries, and more importantly nested queries, and next exists, then correlated query. These are the important topics from where questions were asked. From the below table, gift ID, gift name, price, discount, availability, select max of G1 price from gift G1 where 2 equal, select count of distinct price from gift G2. Okay, this is question about correlated subquery. How correlated subquery to be identified? If the reference of outer query is gift G1 is used in the inner query. When the reference of outer query used in the inner query is executed for once for each row of outer query. But fortunately here, outer query use the same table, inner query also use the same table. Means for each record of gift, every record of gift again it is going to be verified. How? Look, select max of G1 price from gift G1 where 2 equal. What is finding in inner query? Count of distinct price from gift G2 where G1 price less than G2 price. Okay, G1 price less than G2 price. Here, this record is to be compared with every record of the same table. 500 less than 3550. This first record is true for this record, 2, 3, 4, 5. Because G1 price less than G2 price. That 500 is less than with remaining 5 records. So that what is the count? It will give you count of distinct price. Count of distinct price is how many? 3550, 2000, 1500, 3000, 1300. Anyhow, all the prices are different. So it means that there is no meaning of distinct here because it is unnecessary because no distinct prices are there. So how many count? What is the count? Count should be 4. Count is 4, but 2 equal to 4 is wrong. Because 2 equal to 4 is wrong, will this record will be considered for the output? No. For the second record. What is the price? 3550. What is expecting? G1 price less than G2 price. 3550 is not less than with any other records. 3550 is not less than with any other record because this less than condition is failed. So, count will give you 0, 2 equal to 0 is wrong, it means this record also will not come in the output. When you look for this third record, 2000s, 2000s is less than 3550, okay, 2000 is less than 3000s, that is it, only 2 records. Are you getting my point? 2000 is less than with this record as well as this record. It is not less than with any other records. So, means what will be the count? 2, 2 equal to 2 is true, because it is true, this record is going to be selected, fine. And when it comes to this 1500, G1 price less than G2 price, 1500 less than how many prices? 1500 less than 3550, 2000 and 3000s, means it is less than 3 records. Because it is less than 3 records, are you getting my point? Because it is less than 3 records, so count will give you 3, but 2 equal to 3 is wrong, so this record will not be in the output, okay. And when you look for 3000s, 3000s is less than with 3550, that's it now. 3000s is less than 3550 because G1 price less than G2 price. 3000s is less than with only 3550 but not with anyone else. So, that count will be 1, 2 equal to 1 is wrong. So, this record will not be in the output, okay. And last one, this one, sorry, 1500, 3000s is not in the output. Last is 1300. 1300 is less than with 4 records. 1300 is less than with 4 records. Here count will give you 4. 2 equal to 4 is wrong. So, this record also will not be in the output, correct. So, finally, only one record is selected. Which record is selected? G103. G103. And G103 had a price 2000s. That 2000 is less than with 2 other prices, that is 3550 and 3000s. So, that inner query is returned 2 and outer query is comparing 2 equal to 2, correct. It is correct only for this record because only one record is selected. In that it is selecting the max of price because only one record, that will be the maximum price. What will be the maximum price? 2000. Now, question is what will be the output of the above query, that is 2000. Transaction management and concurrency control. In the transaction management and concurrency control, few questions were asked on recoverability and few questions on cascadeless schedules, recoverability, cascadeless. Suppose if Ti and Tj are the two transactions, if I performed an update on some data queue and J reads that update before I commits, what this is called? Dirty read. This is called dirty read. If it is a dirty read, it is mean that J depends on I. Now, when J committed is important. If J commits before I, it is non-recoverability case. If J commits after I, because J depends on I, let I to commit first, later J should commit. If J commits after I, then it is called recoverable schedule. This point you have to focus. And if there is a dependency, means if there is a dirty read, we had a problem of cascading rollbacks. Based on this point, we have discussed multiple questions and that could be easy to understand. Here it is a dirty read, simple, and 2 committed before this, it is not recoverable. And do you have any dirty reads? no dirty read, the schedule is recoverable. Finish. Schedule 1 is not recoverable, schedule 2 is recoverable. Schedule 1 is not recoverable, but the schedule 2 is cascadeless schedule. Okay. Why? Because no dirty read means it is cascadeless and also recoverable. That is perfect. That is an option C. What is a conflict serializability? What are the conflict operations? Read 1 of Q, write 2 of Q. Okay, just I, J I can say. Read write conflict. Write I of Q, read J of Q. Write read conflict. Write I of Q, write J of Q. Write write conflicts. If these conflicts are same in two schedules, then the two schedules are conflict equivalent. And assuming one schedule is concurrent schedule and another schedule is serial schedule and both are conflict equivalent, then this concurrent schedule is said to be conflict serializable schedule. How to check for conflict serializability? Conflict serializability is to be tested based on the precedence graph, correct? Means we have to draw the graph where each transaction should have one vertex. If there is a conflict from I to J, there is an edge. If there is a conflict from J to I, that is also edge. If there is a cycle, not CS. If there is a cycle, not CS. If no cycle, we can say that it is CS. Cycle, no cycle. That case we have to check. Is it has a cycle and no cycle? Consider the following schedule. S1 and S2, two schedules are given. The question is identify the schedules that are conflict serializable. Which schedules are conflict serializable is the question. Okay. Now, how to solve this question? For S1, we have to draw the precedence graph. By looking, we can understand the subscripted number. There are two transactions. And what are the conflicts? Read X conflict with write X of other transaction, one conflict with 2. So, 1 to 2 is an edge. And write X, this is one conflict with read, already 1 to 2 there. And this is same transaction, not conflicts. And this is why no more conflicts. So, we can say S1 is CS. What about S2? We have a two transactions, two vertices. Read 1 X conflict with write 2 X, 1 to 2 is a conflict. Write 1 conflict with write 2. Read 2 X conflict with 2 to same, but this is a Y, no conflicts. I think it is also CS. It means both the schedules are conflict serializable. Answer is both. Next, we will go for indexing. In indexing, we have discussed various concepts. That beautiful concepts, and concepts are on concept oriented, like questions are on concept oriented. It is not based on formula. On indexing, we have started with single level indexes. In single level index, we have primary, clustered and secondary index. And primary index is created on primary key of the file and the file should be ordered. Clustered index is created on non-key but file should be ordered. And secondary index on candidate key or non-key but file is unordered. But what is recommended? Recommended candidate key plus unordered on secondary index. And any of the single level indexes can be converted into multi-level index. And multi-level index can be implemented with tree structure called B tree and B plus tree structure. And when it comes to the B tree provides direct access. These are the important point I am just revising. And when it comes to the B plus tree, provides ordered access. it means B tree requires to search for the keys in levels by levels, and B plus tree will start from the root and come to the leaf, and it will go horizontally because all records are there in the leaf level, ordered axis. And in both of them, the order of B tree and B plus tree is important. What is the order? I always suggested keep in mind what is the structure of a B tree node. B tree node should have n pointers and n minus 1, n pointers, n minus 1 key plus record pointers, n pointers, n block pointers, and n minus 1 key and record pointers. When it comes to the B plus tree, because orders are important, very important, I can say, instead of important, I can say very important. And orders, we have two things, again, leaf node order, internal node order. What is there in the B plus tree leaf node? In the B plus tree leaf node, we have n key plus record pointers and 1 block pointer. That's it. 1 block pointer to point in the next node in the leaf level. When it comes to the internal node, n pointers are n block pointers and n minus 1 keys. N block pointers and n minus 1 keys. And undoubtedly, these orders are very important. I told you multiple times, remember the structure so that you can write formula, then and there only you can answer the questions. Order of internal node. Just now I told you, internal node will have n pointers. What is a block pointer size? Block pointer is 6. N minus 1 keys. What is a key field? 9 bytes. This total size should be less than or equal to block size. That's it. That is 6n plus 9n minus 9 less than or equal to 512. That is 15n less than or equal to, when minus 9 goes to that side, plus 9, 521. So, n less than or equal to 521 by 15, which is less than or equal to 15 3s are 45, 71 means 34. This is internal node order. The question is about internal and leaf. First, internal 34, option A wrong, option C wrong. Okay, leaf we have to look. What a leaf node should contain, only that you remember, that thing you remember. What leaf node contains? N key plus record pointers and 1 block pointer less than or equal to 512. That is 16 and less than or equal, when plus 6 goes to that side, minus 6, that is 506, n less than or equal to 506 by 16. So, we have to take the lower bound, okay, because less than or equal. So, 16 3s are 48, 26 means 31. So, leaf node will be 31. So, option D is wrong, option B is correct. If you delete key 11, okay, where is key 11? Here, here also. And by looking what we understand, order is 1, 2, 3, 4, order is 4, order equal to 4 pointers. Minimum order is 50%, 2. Minimum order is 50%, 2 means 2 pointers. If 2 pointers, how many keys? 1 key. If 11 is deleted from this place and this place, we do not have any change in the leaf node because already it is having 1 key. But how do you manage this deletion? Because 11 is deleted even from the internal node. But you look at this tree, 11's right will have 11. It means this tree is satisfying a rule that left is less than right is greater than or equal to. So, but this node to point here in the place of 11, we should expect 1 key. what is expected, and whatever is there in the internal only copies, which copy we have to keep? The copy of 17 we have to keep here, right? And no more modifications are required. So what options are given? A node with value 11 is deleted from only leaf, because only leaf it is incorrect. It should be deleted from leaf as well as internal. Node with value 11 is deleted from both leaf and internal. Yes, perfect. And no change is needed to the tree, but one change is required in the internal node. That's why it is incorrect. Node with value 11 is deleted from both leaf and internal node, and the value 17 will be merged with 9 and 10. But is 17 will be merged? No. Right. Merging is also one of the solution. Okay, we'll keep aside. Actually, merging is not required. Simply, we can keep a copy of 17 there. But if that option is there, we have to select it. If because that option is not there, we just will keep it. Because here one place is there, if you merge it, also will be the solution. That is called merging. But that is not required, but okay. Deleting the key value 11 is not possible, but it is possible. So that option D is wrong. What is left is option C. Instead of keeping a 17 copy here, even this 17 if it is merged here, that is also a solution. That is also a solution. Okay. So the perfect answer for this question is option C. Which of the following operations can be performed on data cube? What are the OLAP operations performed on data cube? Slice, dice, roll up. But it is not normalize. So what is the answer for these questions? A, B and D. Okay. Just I want to conclude with only one thing. Like हिंदी में एक कहावत होता है, like जीत और हार तो परिणाम है, कोशिश करना हमारा काम है, कोशिश करते ही रहिए. So forget about whether you are going to get very good rank or not getting the rank. Forget about the rank, what you are going to get it. But I suggest you do your best, give your best, and don't give up. कोशिश करते ही रहिए, जो भी हो, like whether you are going to get, because very less time is there, hardly 20 days more to write the GATE exam. Now don't think about whether can I get below 1000 rank, below 500 rank, because these times people are asking me. But don't ask about it, okay? You may get below 1000 or below 500, you may get Air India 1, right? All India rank 1, you may get it, okay? Air 1, you may get it. But forget about that rank, yaar. This time, you just give your best. Never give up, कोशिश करते ही रहिए. और एक कहावत है, भागो और कम से कम अपनी घुटने पे चल, पर रुकना मत. Don't stop. You may run, you may crawl, you may walk, you may crawl, but don't stop. Continue, you study, and so that you can achieve your goals one day or other day, definitely. But this time, don't think about the jeet or har. Like, don't think about winning or losing. Give your best, okay? कोशिश करते ही रहिए. Do your best, and thank you one and all once again. And always, I'm yours, Ramesh Masuna, signing off. Fine, thank you one and all. Bye bye. See you. Good day. Thank you.